Today's topic is verbal and applied problems using quadratic equations. This will be a three-part lesson, so you can put May 13th, and this will be part 1. This is what your note packet looks like. There's 3 pages here and 3 more pages, but again, this will take us 3 days to go through. We're going to go back to our word problems. That's what an applied problem is. We're going to go back to what we learned in Unit 3. So the first type of applied quadratic is just simply a number problem. So in example 1, it says the square of a number decreased by 4 times the number equals 21. With all word problems, we want to define our variable. So they just keep talking about the number. So we'll say let x equal the number. From there, we want to translate the sentence into an equation. So the square of a number, x squared, decreased by is subtraction. And when you see equals, we'll have our equal sign. So this is the equation that I come up with. And again, I notice that it is quadratic, and all of the problems today should be. So I'm going to move all my terms to the same side and set it equal to 0. The simplest technique is to use product sum. So if you can find factors that multiply to negative 21 and add up to negative 4, we can go ahead and factor that. So my 2 binomial factors will be x minus 7 and x plus 3. I'm going to set each of those factors equal to 0, so I have a root at 7 and a root at negative 3. Now there was no restriction on what the number could be. It didn't say positive or negative. So both of these solutions will actually work. We're going to write a conclusion instead of a solution set. So the number could be 7 or negative 3. In number 2, we're going to go back to reviewing consecutive integers. So be careful with the description. It says the product of 2 consecutive positive even integers is 80. So when you deal with consecutive evens, we know the first one is always x. But to get to the next even number, I'm going to have to go 2 digits away. So the next consecutive even integer is x plus 2. And then the third is 2 more away from that, so x plus 4. But it's actually only asking for 2. So it says the product of the 2 consecutive even integers is 80. There's my first consecutive even and my second. I'm going to go ahead and distribute. And when I do that, I'm also going to subtract 80 so that all the terms are on the same side. If we can find 2 factors that multiply to negative 80 and add up to 2, we can separate it into our 2 binomials. So I'm going to use 10 and 8. I'm going to make 10 positive and 8 negative so that I can achieve a positive 2 as my linear term. And then I'm going to set each of these equal to 0. So x minus 8 will give me a root at 8 that's positive and it's even. The other factor will give me a root at negative 10. This is not positive. So even though it's a good solution, we're going to reject this option because it doesn't fit the criteria. So now we'll write our conclusion. The numbers that we're looking for are 8 and 10. In example 3, it says we have 3 brothers have ages that are consecutive even integers. The product of the first and the third. All right, let's define our terms before we decipher this. So x is our first brother. It's an even integer. But I need to jump 2 digits to get to the next even integer, so x plus 2. And then there's 3 boys, so 2 more digits away is x plus 4. Now I'm going to translate the equation, the product of the first term and the third term. X times x plus 4. The word is my equal sign. So the product of the first and the third boy's ages is 20 more, but we're going to push the 20 to the other side to maintain our balance. And then twice the second boy's age, x plus 2. So we're going to go ahead and distribute. I'm going to start to move my terms around. I want everybody to be on the same side. So I'm going to subtract 2x so that it ends up over on the left, but I'm also going to combine my constants of 20 and 4. And now in my last step, I'm going to subtract 24 and set my quadratic equal to 0. So again, I need factors that multiply to negative 24 and add up to 2. And I can use x plus 6 and x minus 4. So I'm going to set each factor equal to 0. So I do have a root at 4 that does meet the criteria. It's an even integer. I have a second root at x equals negative 6. Now it is an even integer. However, the problem says that these boys are having their ages represented by our let statements. You cannot have an age that's negative. So we're going to reject the negative 6 as a solution. And then we're going to go ahead and write a conclusion. So the boys' ages are 4, 6, and 8 years old. In example 4, they're talking about the sum of the squares of 3 consecutive odd integers. Our first integer, of course, is x, but to be the next odd is 2 digits away. So even though they're odd, my next representation is x plus 2. And then there's 3 of them, so I have another odd at x plus 4. So the sum of the squares of the largest and the smallest. We want to make sure we put these into parentheses when we translate. So I'm going to have the smallest x squared and the largest, the quantity of x plus 4 squared. Now it says that that quantity is 353 less than the next part. I'm actually adding the 353 to the left side so that the quantities will be equal. The rest of the problem says 3 times the square of the middle integer. 3 times the square. So I need this quantity, x plus 2 in parentheses, squared. We will want to expand x plus 4 and write it as 2 quantities, the same with x plus 2. So if you want to pause that, you can go ahead and work those out before I reveal the next line. When I distribute the x plus 4 times x plus 4, I get x squared plus 8x plus 16. This is a perfect square trinomial. On the right-hand side, I also have a perfect square trinomial, x squared plus 4x plus 4. I'm going to do a little tidying up and combine like terms on the left, and I'm going to distribute the 3 on the right. And then ultimately, we want all the terms on the same side. I'm going to push all my terms to the right so that my quadratic term is positive. So I'm subtracting 2x squared, I'm subtracting 8x, and I'm subtracting 369. Now 357 is large, but there are factors for it that will add up to 4. And those binomials are x plus 21 and x minus 17. So I'm going to go ahead and set each factor equal to 0. 17 is an odd integer, so it meets the criteria. And x is negative 21. That also is an odd integer. So in this particular problem, we actually have 2 solutions. So in my first solution, I have integers that are negative 21, negative 19, and negative 17. And then if I use the positive root, my integers could be 17, 19, and 21. So we don't want to automatically reject anything because it's negative. It needs to fit into the criteria of the problem, and both of these answers do. Tonight's homework is number 115. You're going to do the circled problems. Please do them on a separate paper, or in your packet if you're doing it on paper. I think the backside is blank. If you have any questions while you're going through your homework, please make sure you get in touch with me. Have a great day.